Well, ladies and gentlemen, it is now time for our first session, which is the opening keynote on the best practices of SD-WAN. For this, we're joined by Zeus Kerravala, ZK Research founder and Principal Analyst, USA. Well, Zeus is the founder and Principal Analyst with the ZK Research. He's somebody who's provided a mix of tactical advice to help his clients in the current business climate and long-term strategic advice. Well, with this, I'd now like to invite him on the stage and screen. The screen is all yours, Zeus. Over to you.
Hi, this is Zeus Kerravala, Principal Analyst at ZK Research, and thanks very much for joining me in this session on SD-WAN best practices. Just before I start, though, I want to give a quick bio on myself. I've been an industry analyst for about 30 or 20 years now, 10 years at Yankee Group and 10 years on my own. I write for a number of technical publications. You can see them here on the screen. Prior to that, though, I was actually a network engineer, and I think the topic of SD-WAN is interesting because even back prior to the term SD-WAN being used, there was a big push by network engineers to try and evolve the network into something that was a little more efficient than the traditional hub and spoke. So I think this is a great session of talking about the best practices and how you can deploy SD-WAN and minimize the risk. Now, I first want to define what SD-WAN is. I want to introduce the term to people who may not be familiar with it. The best way to think about it is that it's a WAN that's optimized for the cloud era. If you think about the traditional MPLS type of network that's hub and spoke in design, that was designed for an era where most of our apps and people and data lived in corporate locations. And so the network that we had was optimized for that. It was designed to send information between data centers and branch offices, even between branch offices. But today, of course, most of our apps and data live in the cloud. And so we know we need a different type of network to do that. SD-WANs leverage a combination of both broadband and private networks. There are different opinions on whether you should go to all broadband WAN or stay with a private network. I'm going to talk a bit about that in my best practices. One of the attributes of an SD-WAN is that it's controlled through software, hence the term software design, and that makes it a lot more agile. Traditional WANs were controlled primarily through hardware. In fact, the control plane and the data plane were very tightly coupled together. And what that meant for a network engineer is that you had to configure the network on a box-by-box basis. And of course, that led to a lot of errors and long troubleshooting times and things like that. So the rise of software-defined networking, which was first implemented in data centers, has now been applied to the WAN and has really had a big transformative effect on the WAN. And so I think what SD-WANs do is it modernizes the network. And if you think of the way the rest of IT has evolved, our apps have been modernized, the way we store things, their compute, those have all been modernized. So what it does is that SD-WANs brings the network into a position where it can keep up with the rest of IT. Now, SD-WANs allow us to do things with our network that we couldn't do before. We can connect home workers easily, we can connect branch offices a lot more cost effectively, but it does raise the bar in complexity. And this is why we need to understand some best practices. If you look at on the left-hand side here on this chart, it shows what a traditional WAN looked like. It was very simple in design, it was very orderly, but it was highly inflexible. So this traditional hub and spoke model that allowed us to connect branches to data centers didn't allow us a lot of flexibility if we wanted to send information between branches. Connecting mobile users, connecting remote workers was very difficult and expensive, but it was fairly simple in design. On the right-hand side, you can see the architecture of an SD-WAN. Of course, there's a lot more connectivity options there. We can connect our data centers and our branches using broadband. We can use wireless technologies like LTE. We can connect directly to clouds, but then it gives us a lot more agility, but it is a little more chaotic in nature in that trying to predict application performance and understand how traffic flows across these things and even when to route traffic down different paths is much more difficult. And so I think from a deployment perspective, even though SD-WANs raise the bar in complexity, if you follow some good best practices, it assures you a smooth transition without that can minimize a lot of the risks in deployment. And so that's what I'm going to talk about in the next handful of slides. In fact, here I've got a summary of the best practices. One is take a hybrid approach. Number 2 is to leverage the cloud. Number 3 is to secure it with SASE. That stands for Secure Access Service Edge. We'll define that, talk about that. That's been it's been associated with SD-WAN. It's not necessarily a core component of it, but the two typically get deployed together. You want to manage it with artificial intelligence. And lastly, adopt managed services. So I'm going to go into each one of these in a little bit more detail now. It's important to take a hybrid approach to SD-WANs. I know there's a lot of hype and rhetoric around networking now that says MPLS is dead and you can go to an all broadband WAN, but that's just not true, especially for larger organizations that have global networks. Private networks do offer superior performance, particularly with long distance connections. When you start talking about connecting transatlantic or trans-Pacific networks together, you get a lot of variability when you use the internet. It creates unpredictability in application performance, and that leads to inconsistency of experience, where an MPLS connection may not be the best performing network 100% of the time, but it's very consistent, and so it's easier to manage application experience, easier to manage users, things like that. Network experience, or networks today, of course, play a very key role in the quality of experience. We live in a world where customer experience and employee experience is everything. And so having a network that's predictable in nature allows us to manage those experiences better. And all broadband WAN, while it may be cheaper, and in some instances it's not always, it can lead to unpredictable and inconsistent application performance. And that, of course, is bad for the IT department, it's bad for users. And so I think this hybrid approach works well. In fact, I'm able to quantify the benefits of the hybrid approach on this slide, where I've compared the internet variability versus MPLS variability, internet response time versus MPLS response times across a number of different global connections. And you can see, for instance, in the Dallas, connecting Dubai to Dallas, the internet has a variability of about 153%, where MPLS has only 12%. Average internet response time is 1.19 seconds for the internet, where it's only 3/8 of a second for MPLS. So that's a huge difference in what you get with MPLS and what you get with the internet. You can see the connecting London to Mumbai, the internet variability is over 200%, where it's only 15% for MPLS. The internet response time is a whopping 4.24 seconds, and that has a lot to do with the way the internet's designed in the India region, versus only 0.19 seconds for MPLS. And so you can see I've got also San Jose to Shanghai, Johannesburg to Dubai. These are huge differences, and this is really the key as to why you should take a hybrid approach. I'm not saying you can't use the internet for best effort traffic. Things like email works great with that, but when you're talking about doing voice and video type of traffic, the performance consistency that you get from MPLS is going to serve you a lot better than trying to do everything over the internet. My second best practice is to leverage the cloud. Of course, the cloud has been used in almost every part of IT, from everything from applications to storage, even the communications today, but it really hasn't had a huge impact on networking, but I think it needs to. There are a wide variety of SD-WAN solutions out there for you, and some will allow you to manage it with existing on-prem technology, some have on-prem controllers, or there are a number that actually let you do it in the cloud. And I think with SD-WANs, it's best managed via the cloud. One of the reasons why is it does provide that centralized management. If you think of one of the characteristics that I give of SD-WAN is that it separates the control plane from the data plane. Well, if I can extract all those control elements out and then have them reside in the cloud, now I can manage my network from anywhere. And of course, we live in a hybrid world today. A lot of my IT people will actually be working from home as well. So I can bring up a centralized portal, I can manage my global network, I can make a single change and propagate it across the network, and the cloud gives me really almost unprecedented agility. It allows me to have one-click configuration from everywhere, including people that are working from home. And it centralizes the data, which I'm going to talk about the impact of artificial intelligence in a bit, but if you're going to apply AI to managing the network, you need to have the data centralized. And so That's very difficult to do if I manage my network with a bunch of on-prem controllers, because then I have to aggregate that up, sync the data, things like that. So the cloud gives me that centralized data, centralized management, centralized consistency that allows me to run my network better. The third, I want to secure the network with SASE. As you move to SD-WAN, you're going to do a number of things like provide direct access to the internet from branch offices. You're going to give home workers direct access to the internet as well. And that creates a bunch of backdoors into your organization. With a traditional network, securing that network is relatively simple. You put a firewall, you put intrusion prevention systems, things like that, in your DMZ, and that was your only ingress and egress point for network access. With SD-WAN, you have a lot more points of entry. And so what SASE does is it takes the security, it pushes it into the cloud, and it allows us to do things like use cloud-based firewalls, SWIG, CASB, things like that, that allows us to apply more security in more places. So SASE is really the only way you can apply corporate class security to everybody in the organization, including your home workers. Another thing that SASE does is it provides a path to zero trust networking. So zero trust has become a hot topic, especially with home workers. We want to make sure that we can have a consistent policy across our network, no matter what type of worker that is, and I think SASE leads to that. So SASE is the coming together of network and security, and to me, it's easily the best way to secure a network. I do think with SASE, there are some elements of on-prem security that you look to manage from the cloud, particularly with larger locations. But what SASE does is it gives you that flexibility to deploy corporate-grade security everywhere. Some of the benefits of SASE, you get application quality assurance, because a lot of those network services, things like load balancing, quality of experience, are located in the cloud. Is operationally much more simple, especially on the security side. If you think of the complex task of managing multiple firewalls, even keeping policies up to date across a network of even 100 nodes is incredibly difficult. So the operational simplicity you get from SASE, having everything located in the cloud, allows us to manage our security at scale. It brings enterprise-grade security and networking to home workers, and so that is something that's historically been very difficult to do. You might have been able to do it with VPN, but now you're putting a lot of onus on the end user to understand how to manage that. And that cloud-first model drives much faster innovation. SASE is much better aligned with that post-pandemic world as well. So to me, if you're going to do SD-WAN, you should do SASE. There's some debate, could you do SASE first? Maybe, but I think the two do go hand in hand. Another best practice is managing the network with artificial intelligence. And I think this is an absolute something that you have to do. AI ops, in fact, is the next phase of IT operations. You see it pretty widely deployed in server ops and things like that, and DevOps engineers as well. What AI does is it brings AI-based automation to IT, to the network. The number one cause of downtime today with networks is actually human errors from people making mistakes. AI will eliminate much of that. In fact, most modernized network equipment today is loaded with real-time telemetry information to provide the network engineer more data to be able to manage the network. But of course, that real-time streaming telemetry is an order of magnitude more volume than what most network engineers are used to. So even the most seasoned engineers have difficulty in trying to interpret all the insights in those large volumes of data. But machine learning is always watching, always looking, and can actually correlate a lot of the data, find those key insights, and even move to a predictive management model. So it's much easier to understand when you should upgrade the network or how you should change traffic patterns, things like that. I think AI also increases agility and the automation capabilities. And to me, you really can't run a large SD-WAN without AI. Now, one cautionary point on AI, and a lot of people engineers that I talk to that embark down that path get a little nervous because the AIs aren't always perfect. Sometimes they give recommendations that don't quite make sense. And the threshold for AI to be deployed really shouldn't be perfection. It should be, is it better than what my traditional engineers can do with manual methods. And again, AI being, human error being the #1 cause of downtime, that threshold is pretty low. So the best way to get started with AI is frankly just to do it. And I think if you do that, you'll learn some best practices. Start by using it in recommendation mode, and then eventually allow the systems to run themselves. Lastly, the last best practice is to consider managed services. With traditional networks, managed services were used about 1/3 of the time. And I think we had a lot of good best practices on how to run networks. And so the proclivity to use managed services was relatively low. With SASE, most network engineers are doing things they've never done before, using broadband at large scale, using cloud-based services. And I think the complexity can almost overwhelm you. I think what managed services does is it can mask a lot of the complexity. So SASE is going to, and SD-WAN are going to bring a lot more decisions to make than what you had to deal with traditional networks. And there's a lot more considerations. You know, should you have security local, or should you have it in the cloud? Should I connect things to regional hubs? Should I go hub and spoke? Should I go full mesh? There's just a lot of things to think about that from a best practice standpoint, you may not have considered before. Most businesses don't have the integrated and security networking teams in order to deploy SASE. And I think that's one of the keys for SASE and SD-WAN success. SASE and SD-WAN also require new IT skills. And most of the new equipment they have a number of APIs, they're programmable in nature. And so that's a new skill set that you have to learn as well. I think one of the benefits of managed services provide is they mask a lot of the complexity associated with the implementation of SD-WAN and SASE to make it a lot easier. Another recent innovation with most managed service providers is that they offer co-managed services as well. So if there's certain things that your organization's good at and certain things you're not, you can outsource the things you're not good at, continue to do things that you are, and move into that co-managed offering. And then that might lead to fully managed down the road. It might lead you to bring management back in your organization, but it does give you that flexibility. And I think managed services providers can play a dual role as well, where they can help you evolve the network, and then if you want, they can continue to run the network after that. So anyway, so that's the end of my presentation. I hope you found it useful. Here's my contact information. I can be reached at that email address. You can follow me on Twitter as well at Zeus Kerravala. I just want to finish up with one note. You know, I think we are at a point with SD-WAN where it has reached a certain level of maturity that most of the early adopters have deployed it. I think if you're sitting on the fence and thinking about it, it's definitely time to evolve your network. Certainly if you look at the trends in the workplace of hybrid work, cloud adoption, mobility, that all lends itself to a new type of network. And I think from an SD-WAN perspective, it might look a little daunting, it might look a little intimidating, but if you follow these best practices, I think you can have a fairly comfortable deployment. So if there are any follow-up, please feel free to reach out to me. Thank you very much. I'm Zeus Kerravala. Thanks for watching this.
Well, thank you so much, Zeus, for that amazing opening keynote.